Anyone out on a winter ski tour will often find themselves in potential avalanche terrain. Therefore, you have to address the avalanche danger. The 3x3 filter method has proved to be a fundamental planning tool because it examines every aspect. Here we take a look at 3 pillars: the conditions, the terrain, and the people, so who is on the tour. And then we have these 3 filters. So we plan the whole thing at home or in the cabin, make our preliminary plan. That's our first filter. The second filter is on site, in the mountains. So we go out, we observe, we get an impression, we look at what's going on around us. And the third filter, the third level, is the individual slope. I actually stand in front of my slope and ask, go or no go? And if it's go, what route do I take?
When starting early in the morning, so when we're setting off on a tour, we use the same categories we used in the planning stage. We look at the conditions, namely the snow and avalanche situation, and we look at the weather conditions. For example, is the weather worse than forecast? Is visibility good enough? Are the temperatures higher or lower? Is there much more wind? And speaking of wind, that takes us to avalanche planning or the snow and avalanche situation. For example, has the stronger wind caused more wind-drifted snow, a bigger wind-drifted snow problem? Or, depending on what you had planned, are the other problems more pronounced or less pronounced?
When you're out there, it's very important to keep your eyes and ears open and make observations. The main aim of this is to recognize warning signs. Warning signs include, for example, whoomph sounds, which indicate that initiation and crack propagation are possible. Other warning signs include, of course, fresh avalanches, be they human-triggered, spontaneous, or caused by blasting. And the third warning sign which you look out for is the appearance of cracks when you make tracks on the snowpack. Obviously, we need to leave the track every now and again in order to see this alarm sign at all.
Avalanche theory has developed greatly over the past few years. This is evident by the fact that we now recognize that avalanche problems exist and that there aren't untold thousands of them, just 5. And as users, we can work very well with these 5 avalanche problems. The first avalanche problem is the new snow problem. The new snow problem is relatively easy to grasp. As the name suggests, it concerns new snow and specifically the critical amount of new snow. This means that as a ski tourer, as a free rider, you need to know what the critical amount of new snow is on the day of your tour. And that depends on the general conditions. This means, what is the structure of the old snow surface like? Is it very smooth or is it coarse? Or what is the temperature? Is it very cold? That is to say, is the snow very brittle? Is the new snow very susceptible to stress? Or is it around 0 degrees? Which is more favorable? Another avalanche problem is wind-drifted snow. This wind-drifted snow problem predominantly concerns the combination of loose snow and wind. The wind is the architect of avalanches, and wind deposits snow very unevenly across the terrain. The irregular snow depths lead to tension in the snowpack and the formation of avalanches. This means that in the event of a wind-drifted snow problem, the key aim is to identify the locations of fresh snowdrifts. The wind transports the snow from the windward to the leeward side, so from the exposed side to the sheltered side. And the snow collects on the leeward side, that's where the wind-drifted snow is, and these snowdrifts must be avoided. Wind signs that hint at where wind-drifted snow is located include, for example, sastrugi, the structured surfaces with peaks pointing toward the direction the snow is coming from. Cornices, snow banners on ridges, and wind-scoured ridges can also hint at the location of wind-drifted snow. One avalanche problem that is very easy to identify is the wet snow problem. As the name suggests, the snowpack is wet, and when the entire snowpack is wet, it loses all stability. So in the event of a wet snow problem, you simply have to be careful and observe how severe the degree of water infiltration is. Typically, the wet snow problem occurs in spring, when the snowpack gets more and more wet due to rising daytime temperatures and sun exposure, meaning stability is lost and wet snow avalanches occur. Gliding snow problems only occur in areas where the ground is smooth. That means on meadows, on steep meadows, or on rock slabs. Because the danger is indicated by gliding snow cracks, they are very easy to deal with and don't usually pose major problems for tours. Of all the avalanche problems, the most difficult to identify is the persistent weak layer problem. With new snow, you can see the new snow. With wind-drifted snow, you can see the wind signs. With wet snow, you can see the wet snow. And with the gliding snow problem, you can see the avalanche mouths or fish mouths. But you can't see persistent weak layers at all on the surface. This means that planning and the information from the avalanche bulletin are particularly important. As an alternative, or in addition to this, in the event of a persistent weak layer problem, it makes sense to carry out a snowpack test, because this way you can identify the weak layer in the old snowpack. Whether you conduct the snowpack test out on the mountain depends heavily on the avalanche situation. If the situation is clear because you hear whump sounds and rumbling everywhere, we're hardly going to start digging holes. If there is a persistent weak layer problem and the situation has been this way for a while and we're not quite sure whether the weak layer still persists, whether it is still susceptible to stress, then it makes sense to dig into the snowpack to get a more accurate picture of the snowpack structure. The slope angle is an important criterion for assessing avalanche danger. Snow starts to slide at 30 degrees, so 30 degrees is the magic threshold. At this steepness, avalanches start to occur. The typical slope steepness in avalanche release areas is 38 degrees, and we can use the slope steepness to estimate where certain dangerous areas in the terrain are lying in wait for us, and we can also get a rough idea of how likely an avalanche is. The steeper the terrain, the more likely an avalanche. It is important that we learn to estimate slope steepness. We don't always want to travel straight to the slope. We want to assess so we can measure the slope steepness there. We don't want to expose ourselves to this danger. This means when we're out in the mountains and see a slope, we can make an initial estimate. Is it 35 degrees or more like 40 degrees? And with a map, with a modern digital topography map, we can check our estimate. If you can successfully identify 30-degree slopes in the mountains, take adjacent areas into account, and also know the classic rules of thumb, for example, that on slopes of 30 degrees or steeper, you have to make use of kick turns on the ascent, then you have all of the skills you need to lay good tracks. One more indication: rocky terrain is often free of snow. So places where the rocks peek through are often steeper than 40 degrees. The recommended way to train yourself to estimate slope steepness is to frequently check your estimate by actually measuring it. The best way to do this is using your cell phone by lying a pole down on the slope and simply measuring it using your cell phone's inclinometer function. Alternatively, you can use the ski pole pendulum test. Of course, another very helpful aid is a slope angle map, which can provide us with good information about the class of slope steepness we will be traveling on before we set off. The topography also plays a part in avalanche triggering. Small-scale terrain differences can tip the scales, always depending on the avalanche problem. In the event of a wind-drifted snow problem, ridges are often favorable because the wind blows away the snow and transports it, perhaps to a nearby bowl where snowdrifts will form. In the event of persistent weak layers, the situation can be very different. In this case, the bowl might be favorable because there's a great deal of snow there and the weak layer is very deep down. In the area with little snow near the bowl or at the foot of the slope, it is more likely that you will trigger the persistent weak layer problem because the weak layer is close to your skis. Another important point concerns the consequences. This means that we also need to be able to identify terrain traps in the mountains. Terrain traps include, for example, areas above rock faces or steep escarpments, ditches or gullies that you can either fall into or in which you would be buried very deeply. The third and final thing is the group, so the people factor. Clarify once again, how is everyone's state of mind on the day? How fit are they? Has everyone got everything they need? You need a full set of equipment. For example, you could be out on glaciated terrain, and then it's important that you have everything you need to rope up or carry out a crevasse rescue. There are several standard procedures that are highly recommended in the mountains. One of these is maintaining intervals. On slopes of 30 degrees and above, you should maintain load-reducing intervals. The aim of this is to prevent the snowpack being overloaded and has the advantage of you not getting in the way of each other when making kick turns. In the event of an avalanche, these intervals also have the advantage of fewer people being buried rather than the entire group. Another standard measure is maintaining distances on the descent. This means that slopes steeper than 30 degrees should be skied individually from one safe point to the next. Selecting the right assembly point is particularly crucial, and you should definitely proceed extremely carefully here. Safe assembly points are often a bit further away from the foot of the slope, which means you don't come to a stop right at the end of the slope. Instead, you might move further to the side or to a point of higher elevation. Safe assembly points also depend on the size of the slope. In other words, you should always have 20 to 30 meters distance from a slope. On big slopes, it's recommended that you make your assembly point even further away. And that's why it's important to communicate the assembly points well within the group, so that everyone knows how far they have to travel to get to safety.
To prevent measures getting diminished, it is recommended that you only take them or order them if they are appropriate. Otherwise, at some point, people will stop seeing the sense of these measures.
Nothing reflects the ability and knowledge of a ski tour quite like the capacity to move optimally in the mountains. Avoiding dangerous areas and terrain traps and making use of favorable terrain features are things that need to be learned. It's a learning process that spans years, decades, but that's what makes ski touring exciting. And if you stick to it, you'll always be able to enjoy safe and wonderful experiences.
Einhält, dann hat man immer sichere und schöne Erlebnisse.